All right, when we learn a new programming language, we usually get stuck on the what and the how. But today, we're going to dig a lot deeper. We're going to get into the why. We're deconstructing the core philosophy behind Clojure, and we're doing it by going straight to the source, its creator, Rich Hickey. So let's dive in. And yeah, we are starting with a bang. This quote from Rich Hickey is a direct shot at one of the most established paradigms in all of software. I mean, that is a bold claim, but it's not just for show. It's rooted in a really specific and, I think, fascinating set of design principles.
And just so we're all on the same page, we're not just guessing here. Everything we're talking about today is distilled from years and years of Hickey's own talks and writings about why Clojure is the way it is. We're getting the philosophy right from the architect himself.
So let's start with the first, most fundamental problem every single one of us faces as a developer. How do we even represent information in our systems? Clojure's answer starts by making a really crucial distinction.
It sounds like such a simple question, right? But the answer you pick has these massive downstream effects on pretty much everything. Complexity, correctness, even your basic ability to think about your own code. So in Hickey's world, the word data has a very precise meaning. It's just a recording of the past. It's a fact. You know, the king is dead. It's not an opinion. It doesn't change. And this is the key part. It can't do anything on its own. It just is.
And this brings us to a critical contrast. On one side, you've got data. Simple, reproducible facts. On the other side, you have what Hickey brilliantly calls ambassadors, which is his word for objects. Think about it. If you ask an ambassador a question, you might get a different answer depending on what day it is. They mix up facts with their own opinions. And you always have to worry that some simple question you ask might, metaphorically start a war.
And this just nails the core argument, doesn't it? I mean, imagine if scientific data behaved like objects, changing its answers, having all these side effects. Progress would be absolutely impossible. The entire foundation of reasoning is built on stable, unchangeable fact. The whole goal here is to bring that same stability into the world of software.
Okay. So if our information is just a collection of immutable facts, how do we handle the reality that things do change over time? This brings us to the second huge problem, managing state, especially when you've got a bunch of things happening all at once.
Clojure's answer is kinda radical in its simplicity. Instead of making everything mutable by default and then having to add locks and all this crazy complexity later, it just flips the script entirely. Immutability is the default. Change becomes the explicit, carefully managed exception, not the rule. Now, this is the first question pretty much everyone asks. I mean, if you can't change a variable inside a loop, how do you even write one? It seems like this huge, unnecessary restriction, but it's actually a key, deliberate design choice. So here's the crucial insight. By not letting those local variables change, Clojure stops you from accidentally creating a super dangerous situation. It's like sending a spy on a mission with a briefing that can be secretly edited by someone else after the spy has already left. It just leads to chaos. This one design choice gets rid of a whole category of nasty bugs in multi-threaded programs and forces you into a safer pattern right from the start.
Okay, let's get a little more technical for a second. A lot of functional languages have this feature called tail call optimization, or TCO, which makes recursion really efficient. So why doesn't Clojure have it everywhere? This breakdown shows some deep pragmatism. The core problem is that full-blown TCO just isn't possible on the Java virtual machine without breaking compatibility with Java. Now, the easy way out would be some kind of partial fix, but Hickey saw that as a trap, a false promise, that would just lead to confusion and bugs. So the solution is the recur keyword. It's an explicit, honest contract. It tells you, the programmer, right here and only here, I guarantee this loop won't blow up your memory. It's a choice for clarity over some kind of partial magic. So all these ideas, clean data, managed state, they all build toward our third big problem. How do you let a system grow? How can different people add new behaviors to the same thing without stepping all over each other's toes? This is the extensibility trap. A lot of dynamic languages solve this with monkey patching, where you can just open up someone else's code and shove your own functions in there. But that is a recipe for pure chaos. If Fred adds a bar function and Ethel adds a different bar function, the last one loaded wins. They can't coexist. Clojure's solution is totally different. Functions live in their own namespaces. This means Fred/bar and Ethel/bar are two completely separate things, and the developer can choose exactly which one to use. It's composable by design. This quote is a really fascinating insight. Hickey basically sees those giant switch statements you find in pattern matching as a sign of weakness, a closed way of doing things. It means you have a fixed set of cases you can handle, and that's it. Clojure prefers a more powerful, open kind of polymorphism, where new behaviors for new data types can be added at any time by anyone without ever touching the original code. Isn't that a more powerful way to think about building systems that are meant to last?
So, after all these big philosophical decisions, treating data as facts, defaulting to immutability, designing for open extension, what's the actual payoff? What's in it for the working developer?
Well, here it is. The payoff is simpler code that's way easier to reason about. It's robust concurrency right out of the box, not bolted on as an afterthought. You build systems from composable parts, not these tangled, brittle hierarchies. And you totally avoid huge classes of bugs related to state and time. Ultimately, you get to spend your brainpower on the real problem, manipulating data, not on all that object-oriented ceremony. And let's be really clear about this. This isn't about some abstract academic idea of purity. Every single one of these decisions is a pragmatic, opinionated choice aimed squarely at tackling the immense complexity we face in modern software development. So I'll leave you with this question to chew on. What are the defaults in the languages and tools that you use every single day? And how many of them aren't really laws of nature, but are actually deliberate and maybe even debatable choices, just like the ones we've explored here today?